Hey everybody, this is Coach Harris with another 5-minute math lesson. So today we want to talk about slope. All right, so there's a number of concepts around slope when we're dealing with linear equations or linear functions. Okay, first of all, how do you tell whether or not a line is a positive or has a positive or negative slope? All right, really simply put, if it's going up from the left to the right, so for instance, let's say I've got a line that looks like this. Okay, this is going to have a positive slope. I'm going to look at it, I'm going to assess it from the left side of the graph to the right side of the graph. So when I look, yes, it's going up, that's going to be positive. So conversely, what would a negative sloped line look like? Something like this, okay? So this would be a negative sloped line. Okay, pretty simple, pretty straightforward stuff right there. We'll come back to the graph in just a little bit. There's some other things we need to know about finding slope. How would we find the slope of a line if we knew 2 points but did not have the graph? So let's say I've got a couple points. Let's say I've got the point 1, 3, and I've got the point 5, 6. Remember from my last video, 2 points always define a line. Any 2 points anywhere, I can always connect them with a straight line. So now we are given an equation to find the slope of the line that's defined by these 2 points. The equation looks like this. Slope equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, those can be a little bit overwhelming to people. When you see those sub 1, sub 2s, everything like that, listen, all that is a way of remembering, all right, so I've got x value in one point and x value in a second point, x value in y value in one point, y value in a second point. So how do we make sure we get this right? Always make sure you designate one of the points point 1, the other one point 2. Then that should be so much easier to allow you to know what to plug in where. This becomes the y value in the second point. This is the x value in the second point. This is the y value in the first point. This is the x value in the first point. Now I just plug in the numbers for what I just designated. So for instance, the 6 goes there. The 3 goes there. Okay? The x sub 2, the 5 goes there. And the x sub 1 goes right there. So now we just simply do the math. 6 minus 3 is, I almost said 2, it's actually 3. And then 5 minus 1 is 4. So the slope of the line defined by these 2 points is 3 divided by 4, or 3/4. Now, what does that mean? All right, so let's go back here to the graph. Excuse me, I'm in another person's room today and not mine. So what do we mean by a slope of 3/4? Well, let's convert that to the graph. All right, under the concept of rise over run. Well, vertical movement on the graph is always on the y-axis. So this is change in y. Okay, divided by the change in the x values. So let's say I had a point. I'll also use this point right here, 2, 0. Okay, and I wanted to apply a slope of 3/4. I would go up 1, 2, 3, and to the right 1, 2, 3, and 4. Okay, so you just kind of use your pencil to do that. What does that line now look like? That right there. We've got a rise and a run, a rise of 3, a run of 4. That's how that applies right there. So what we've done so far is finding the slope with 2 points. We've also figured out what rise over run is, okay, graphically. Also, if you got a word problem or something like that, and you're wanting to know what the slope or something like that would be by the linear equation representing a word problem, all right, very often we think of rate or rate of change. I'm going to use it like this, ROC, rate of change. Let's say I had something like Coach Harris is going to Florida over fall break. He's got to rent a car. It's going to cost $75 per day plus a $35 initiation fee. All right, that per day right there means a rate. In essence, a rate of change. Okay, so that would be the slope right there. All right, if I were to write that as an equation in function form or in function notation, it would be f of x equals 75x plus 35. 35 is the standalone amount. 75 is the amount that is connected to the variable, which is how many days he's going to rent the vehicle. Okay? Now, if you take that idea and you back it up a little bit, we were studying sequences before. So let's say I had a look at an arithmetic sequence that looks like this. 1, 5, 9, 13, boom, 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 so on and so forth like that. I think I told you in the video on arithmetic sequences that arithmetic sequences always represent lines. Well, this common difference right here, we can recognize that it's 4. Now, just to let you know, the slope of the line that's represented, or that represents that sequence, is going to be the same thing as the common difference. All right, so we just hit a lot of things really, really fast on that. One more thing I want to show you, and that is when you have an equation that looks like this, 3x plus 5. This is in what's called slope-intercept form, okay? The number that's connected to the variable, all right, it's a coefficient, but I like to say the word connected to it. The number that's connected to the variable is always the slope of the line. Now remember, it's got to be in this form right there. What do we mean that form? Have it solved for y. Hopefully this helps you out with all things slope when it comes to lines and linear functions and equations. Thank you.